This video presents a overview of the ICRFS-Plus modeling frameworks, and we'll start off with what we call the link ratio techniques, which has a bit of a spreadsheet type feel to it. So you can apply your standard link ratio techniques, volume weighted averages, averages without high and low, whatever you like. You can smooth your link ratios and so on, including Bornhuetter-Ferguson and expected loss ratio. Now that particular module can be applied to any incremental triangle or any cumulative triangle. Now it turns out that the ratio is one number divided by another number, so therefore ratio is just the slope of a line between the number pair, y on x is the ratio, so it's just the slope of a line between the origin and the number pair x, y. So any ratio is just the slope of a line or a trend line, and average ratio is just an average slope and an average trend. That means you can estimate average ratios, any type of average, by fitting an average trend line. But when you fit an average trend line, and if you add an error term, in other words the variance of the volatility around the average trend line, you're doing regression. So the extended link ratio family formalizes any link ratio method, any weighted average link ratio method is a regression estimator. For instance, the MAC method is a regression formulation of volume weighted averages. And that's the default method in the extended link ratio family. What are the extensions? One of the extensions is due to Murphy, where instead of forcing the average ratio to go through the origin, there might be an intercept. That's a Murphy extension. Another extension, apart from an intercept, is we might have a constant trend in the incrementals. ELRF only applies to cumulative data. However, another component of the model in the extended model is a constant trend down each development year, across the accident years for each development period. And that's called the extended link ratio family, and it contains a lot of the ratio methods and a lot of their derivatives. Now, what's the advantage of formulating link ratios, average link ratios as regression estimators? Well, the main advantage really is that you know what assumptions the method's actually making. And the whole idea of modeling is to make sure that the assumptions that the method is making are actually assumptions that are in the data. In other words, they're supported by the data. You're assuming the methods make assumptions. They all make assumptions. The question is, it's a very important question, and that is, are those assumptions carried by the data? Are they satisfied by the data? Otherwise, you run tremendous model risk. You're trying to find a model where you actually, or you're looking within a family of models where you're trying to reduce model risk. So ELRF actually tells you the truth, and the truth is that these ratio methods really don't work in terms of measuring the volatility in your data, and they also have a lot of other drawbacks. And that creates the bridge to what we call the Probabilistic Trend Family modeling framework, which of course we'll describe in detail. In the Probabilistic Trend Family modeling framework, it's not one model. You need to design a model that works for your data. It's a model that, in a way, has created your data as a sample path. In that modeling framework, you measure the trends in the three directions, and the quality of the volatility around the trend structure. And any model in PTF is described by 4 graphs. Once you kind of see the 4 graphs, you know what it's telling you about the data. MPTF applies to multiple triangles, multiple lines of business, multiple segments, multiple layers, and so on. So there are unique benefits actually afforded from going from there to here, to the PTF and MPTF modeling framework. And I guess this is a bit of Estoniana at Sydney Harbour Bridge with the Opera House. The ELRF module sort of cajoles you or implores you to leave that and start working with these two modeling frameworks. Best estimates for reserves is used on, a lot of this is covered in the paper, best estimates for reserves. It's on the CIS syllabus of examinations since 2005. The other thing is that once you use ICRFS for a while, you actually get the pleasure of finding things out you never knew before. So you've seen in the previous video that ICRFS-Plus, the database is a repository. You can have a number of databases. You can have your own local database, or you can have a database which is remote. You work on certain projects on your own. At the end of the day or at the end of the week, you take everything in your own database and transfer it to the global database, corporate database, where all actuaries that have access to the corporate database have access to the same information with a few mouse clicks. ICRFS also is COM-enabled, which means you can run the system from outside. You can bring in data writing COM scripts from outside. So if you've got triangles, and this is demonstrated in one of the videos, if you have triangles that reside in any one of these applications, MS Access, Oracle, SQL Server, Excel, you can import them into an ICRFS-Plus relational database. If you don't have triangles, you have what we call unit record transactional data. It resides either in Oracle, MS Access, SQL Server. Again, we can help you write COM scripts. Some of these COM scripts actually come with a system. Some examples. It's Visual Basic and Excel that will allow you to make queries into the unit record and extract any loss development arrays you like. They'll be manipulated by the COM. They'll go into an ICRFS-Plus relational database. When it comes to updating, that can also be automated. Models are also updated when you update the triangle groups, the whole database. You can manipulate objects within the database, object within triangle groups. You can run the modeling with it, all using COM automation. So most of your processes can actually be automated. The only process which isn't automated is the actuary designing a model, one or two models, perhaps designing forecast scenarios with different inflation and different discount rates. The actuary doing the monitoring and the updating models, triangle groups, databases are updated automatically, and if the model's still working, in terms of forecast tracking, you might not even change it, and that's often the case. You run the same report templates. That's also automated. Okay. Let's look at other benefits of ICRFS-Plus. We believe that really it's the only platform, loss reserving, underwriting risks, and so on, that satisfies the requirements for Solvency II. For instance, one of the requirements for Solvency II is to calculate the best estimate. And the definition of best estimate is a probability weighted average, which is a mean. But it's got a mean of some distribution. With ICRFS, you would calculate the mean by calendar year. You have distributions for each calendar year. You have a distribution for the aggregate. And the mean of the aggregate has to be the sum of the means. And anytime you forecast distributions, your assumptions are explicit. They're also auditable. You can monitor them. You know what assumptions you're making about the future. So you have one relational database that facilitates the understanding of the significant long-tail liability risks on the enterprise in a quantifiable and integrated manner. You've got probability distributions that I mentioned before by calendar year. You've got capital allocation. You can calculate these TVARs and VARs and you know what explicit assumptions you're making in calculating these distributions and these risk measures. Okay, some unique benefits of the product. No two companies are the same. One of the benefits of the product, you might remember, is that COM automation, importing data. Well, if you've got the AM Best or an IIC, Schedule PC, CD, or the S&P synthesis, which is based on the FSA returns, you can import all that automatically into an ICRFS-Plus relational database, and that is shown in one of the training videos. You'll see that no two companies are the same for the same line of business. They don't write the same mix of risks. They're not the same. There are myths about total reserve upgrades or increases. It's on ICRFS type models, and you know what assumptions going forward will give you consistent estimates of prior year ultimates on updating. Every year, suppose you do your monitoring and evaluation at the end of each calendar year. At the end of each calendar year, you have another calendar years of data. How do you know whether your estimates of prior year ultimates are consistent from year to year? Under what assumptions are they consistent? This is the kind of things you'll learn, and you'll know using the system, using the modeling frameworks, when they, in fact, you would expect them to be consistent. Under what conditions are prior year ultimates and updating consistent? We're going to study the difference between uncertainty and variability. They are two different concepts. You get unique e-support with the product. Anytime you have a problem, you email to support@insurer.com. It's very easy to communicate in terms of models. All you do is create a new database, copy and paste that specific triangle group into a new database. Your model's already there. You might put into the notes, can you comment on these, can somebody in Insurer comment on these models? We look at them for the pictures, we know exactly what you did, and we might provide an alternative model, some comment on which model might be best and which forecasting scenario might be best. The system is also used for prospective and retrospective stop-loss layers, pricing, stop-loss, different layers, many different insurance structures. You can design optimal retention for your long-tail liabilities. A lot of advantages. And some of them are going over again: comp technology, relational database, company-wide report, one report template. AM Best, NIC, Schedule P, and S&P synthesis can all be converted in one fell swoop to ICRFS database. You also have a modeling wizard, although you'll learn how to model data manually and test the modeling with it. You can model net of reinsurance versus gross data and find out whether outgoing reinsurance has been optimal. We look at case reserve estimates. We also model the number of claims closed and relate those to the paid losses. Monitoring and updating, I've mentioned that before, I tend to repeat myself, is a great advantage. Diversification between LRBs. There's credibility modeling, pricing future underwriting years, optimal outgoing reinsurance, well, that's related to optimal retention. You can also price high severity, low frequency, uneven sampling periods. Well, let's look at an example. So if you haven't opened your database, I'll just wait for you. Go to Open and open Workbook 104A. Mine's already been open, so I can close it, close the previous one. That's a new opening. Let's go to a triangle group called C. So I click on C, and C uneven. Open that. Look at the shape. Open that. Triangle. That's what it looks like. It's actually accident year by quarter year. So if you want to do quarterly reviews, but on 12 months accident year reserves, you'll create a triangle group where the dimensions are, for the rows you have accident years, but for the development periods and calendar periods you have quarter years. So you're doing quarterly review. So the next quarter, there'd be a value there, one there, and if you're still writing the business next year, you'll have 2001 quarter 0. We start our development periods at 0. And this way, the accident period, no, not for quarterly data, for yearly data or some dimension data, the accident period, some sampling periods in each direction, I meant, the accident period plus the development period equals the calendar period. Okay, so you can also model uneven sampling periods, accident periods by quarter periods by month, and so on. Okay, for the multiple triangle or the multiple PTF modeling framework, there are also lots of advantages. We use the MPTF, modeling multiple lines of business, diversification, capital allocation for both underwriting risk, reserve risk, the combined risk. You can model multiple segments, medical versus indemnity, same line, different states, gross versus net of reinsurance, layers including high severity, low frequency. There's credibility modeling. You'll see examples of that in some of the training videos. Only a few years of data are available, and you use a bigger triangle. You might have a small triangle. You might use a much bigger one. To credibility adjust some of these parameters here using the larger triangle, also trying to work out what's happening in these development years. You might have a triangle with high process variability, and you might credibility adjust some of the parameters statistically, those that need adjusting using industry data. If there's no correspondence in terms of features between the industry data and this particular company, well, statistically you shouldn't be adjusting any of the trend parameters. We never really adjust process variability. Process variability is innate in the company. Benefits of diversification. If you're buying a new company, you want to see if any of its lines of business are correlated to what you're writing. And if they are, then the price should be less, should be lower. If you're writing new business, how is it related to what is already on the books? Okay. I think that's it for this particular video. So most of it was just sort of pedagogical with very little sort of